Okay, part 2 happens to be phase 2. So MIS chapter 10, part 2. So let's continue on with the system development lifecycle. Phase 1 was all about planning. So we wanted to make sure we definitely knew what the problem was. What do the users really need? Because if we don't know that, then creating the new system is not going to make any sense. So assuming we've got all our planning done, just like with a home, you really know what you want. How many bedrooms? What's your budget? What are my alternatives? What part of town? What kind of materials and stuff comes later. So now we're gathering and analyzing. We make sure we really have a clear idea of what the problem is and what are some of my possible alternatives. Again, with a house, many different alternatives. You could build a house out of wood. You could put in a steel house. You could build it out of adobe. There's many options. So what we want to do now is we want to look at, after we look at that, now we look at the design. So phase 3 is the design. And again, I can go into much more detail, but of course you are reading the chapters as well. So that will explain in more detail. So the most realistic solution, like what's going to really pay off for us? What are some things we want to do? And here's where you really detail. What is it we want to do? Just like in a house. You design the roof, the structure, the shape on the lot, all that kind of stuff. Where's the plumbing and electrical? So the document is created with the exact specifications for putting it into place. Files, databases, forms, and reports. In class, I often ask a little quiz. What is most important to design? The input, the output, the programs, or the database? What do we design first? They are all important. Input, output, database, or the programs themselves. And I would have a long pause in class. Well, most people guess incorrectly, but the first thing you need to design is the output. Just like a house, what do you want it to look like? What are the reports we need from this? That's what it's all about. What are the forms and reports that this will generate? Then I go backward and say, what files do I need? What do I put in the database to generate the reports? We want payroll reports, inventory reports, accounting reports, whatever it is designed for. Again, what's the logic? What's the physical design? What's the concept? What am I really trying to do here? We're not into hardware and software at this point. And then what's often done is something called a prototype. That's just like if you were ordering a custom yacht or an airplane or an apartment building. Often you would get a small scale version of it. This is so the users now can offer some feedback. They can say, ooh, I love it. Or that font doesn't work, the colors don't work, the overall design doesn't work. It really is nice if you can do this. And there's lots of ways of doing this, such as with Microsoft Access. So why do we do this? It's really kind of giving a proof of concept prototype. It helps sell it because we need the users and management to get on board with whatever the project is. Otherwise, we're wasting our time. And so this prototype helps give an idea of what it's going to look like. We'll look at, is it really feasible? And we get an idea for systems requirements. So the biggest part of all this, now after we've done everything, it's kind of like with a house. Now is when it's time to build it. We're actually going to create this thing. So with a program, we're turning it from paper into action. Probably we're going to need some computer systems. Not 100%, but quite likely. We may have to train some people on how to work this. What's the physical layout of it? Coding and testing, that's basically writing the programs and testing them. So there's lots of designing and then lots of coding and testing in the implementation phase. So another thing is, and this is what can take a long time, this can take a year or more to do all this. Security measures, safeguards, backup, disaster recovery, all this kind of stuff. And what's important for testing, for the midterm as well, how do we convert from the old system to the new system? So I'll cover some of the basics. There's basically 4 ways you can do it, or some combination. So we had an old system, payroll. Let's use an example of payroll. Well, how do we get into the new system? maybe we run them both simultaneously. So we'll say, hey, let's enter everyone's data in the old system and run it, and at the same time let's run the data in the new system, and we'll compare our output. That's safe, but it's a lot of extra work. It may be something that you just don't have the time, equipment, manpower to do both. Phase in, phase out. This is very common for accounting systems. Maybe all of the accounts payable, the new ones come in on and we handle them in the new system. As we pay off all our bills, we phase out the old system. And then when that's working fine, everything's up and running, then we start doing it with payroll or accounts receivable or something like that. So we can, piece by piece, bring in chunks of the new one, get rid of old one. So every system can be a little different. Maybe we have a direct or plunge conversion. That's kind of like driving your car into a car dealership, and you hand the keys of your old car, you buy a new car and drive home with a new one. So the old system is stopped one day and the new system is used right away. That sounds great, but it could have some problems if something doesn't work right. What's also very common is what's called a pilot conversion. An example I like to give is something like, let's say you're at Albertsons or Vaughn's or somewhere. Maybe one of the checkout stations will use the new one. So all the checkers can take turns being trained on the new system. And if there's any problem, you just close that checkout lane. Just close that cash register and route people to the old ones. It's a great way to implement it, get people up and running. But if there's a bug, I can jump back to the old one. So there's a lot of different ways you can do this. All at once, different stages, etc. So I would highly recommend you review those, at least for the exams. So how do we, so one of our really nice options, rather than building an entire information system, what is very common today is we put what's called an RFP. And all that is a request for proposal. We write down and document exactly what we want. We request bids for equipment, supplies, services, etc. And this is exactly what happens in the real world for if you want to have a big commercial building built, or you want a custom yacht built, or an airplane, or a custom house. You say, this is what I want, and the vendors, potential vendors, can propose their bid. And so there's some advantages and disadvantages. One big advantage is all vendors get the same information. For a large government contract, this is a requirement by law many times. We have to put out to several bidders so we can get a fair competitive bid. Disadvantages can take a long time. Sometimes you're already used to working with one vendor, and it would possibly be a lot faster to just work with them. But again, then you may not get the best deal. So who knows? Okay, so how else can I get this? I could program it all myself. We could create it all, but let's go back to Grandpa's surf shop. You don't have anybody there who knows how to do this. Okay, so another thing is you could do what's called self-sourcing. That means the end users build pieces of it themselves, kind of like with Access databases and spreadsheets and things like that. Maybe they use some off-the-shelf software, and they can do the payroll, or another one can do the inventory control. So that is a viable alternative. And in a large company, if there's a lot of backlogged projects, it may be much faster to do some of that. It's flexible, but there's some downsides too. You may be creating excess data. You may not have access to certain kinds of data. If the person that creates it gets promoted or moved or quits, maybe nobody knows how the heck this worked. Inadequate security. It's quite common that somebody may take home files, intentionally or not, that end up on their home computers, which has valuable company data. So it may not be up to good standards. There may not be any training. So there's lots of disadvantages. But that's the real world today. I have in my desk lots of spreadsheets that handle what I need to have done, but I'm pretty good at this. But anyway, that's another option. So ideally, organizations have some kind of guidelines. If it's something that's with critical data, you probably don't want just the end users creating all their own databases and things like that. Now, outsourcing, that is, we hire an external vendor. And all of you have heard, of course, of much programming work going over to India or places overseas, but it could just be somewhere outside of our organization. Now, assuming we've got the system completed, we have to, for the rest of our time with it, is maintain it. Things change. We may enhance it or make some modifications, add or replace or upgrade hardware and software. So that's going to be going on, again, just like if you bought a house. So there are some new trends in this too. There's a lot of new things, and we'll say this may not be appropriate. May not be appropriate if it's not really clear what needs to be done. Maybe this is just, we're kind of winging it and it's fast, or the user's needs are changing. Maybe you're merging with another company, you're buying and selling resources or bringing on new people. So this system development life cycle is really nice if you have the time, the money, and the resources. There's something called Rapid Application Development, or RAD programming. It deals a lot with getting the users involved. It's what we call an iterative process. It's kind of, I do something, I get some feedback, I make some changes, I get some feedback, I test it, I fix some things, and it's generally not the highest quality, but it can be much faster. Hence the name Rapid. Extreme programming. So there's a lot of new techniques. You're going to see some of this terminology in the chapter. Basically, this is all about smaller functions. Maybe people just work on gathering the data for payroll, and then another small team works on just processing the functions, the programs for payroll or inventory control or whatever the heck it is you're doing. By the way, in the real world, nobody will probably, very rarely will somebody program another payroll system because it's already been done and it doesn't change that much. Okay, pair programming, a very cool idea. Getting two people at one workstation. So this is like one guy's typing it out. It's kind of like you and your buddy getting together to work on a term paper. Somebody's writing, somebody's looking for mistakes, somebody's doing some thinking while the other one's typing. And then we use what's called a library. Sometimes there's lots of reusable pieces that we can just plug in, that we don't have to program again from scratch. And there's several different techniques. Agile methodology. It's again on a smaller scope, and it's just really about getting little pieces done here and there. So here's some of the key terms for the chapter. I highly recommend you read the chapter. If any of you are thinking of careers as a programmer or a systems analyst, whether you choose the computer science route or the business route, this is a very viable career. Systems analysis, designing new systems, and helping companies get up to speed. Okay, I wish you the best. Feel free to ask any questions you have, and enjoy the chapter.